A particle initially at the point with position vector negative 6i minus 10j meters moves with a constant velocity 3i plus 2j meters per second. Find the position of the particle 8 seconds later, the time at which it is due south of the origin, and the time at which it is due east of the origin. So we have a particle that's initially here at negative 6, negative 10, and it moves like so. So in part A, we're going to use r is equal to r0 plus ut, because of course it's moving with constant velocity. So r is going to be negative 6, negative 10, so that's the initial position, plus 8, which is the time, times the velocity vector, which is 3, 2. So that just gives us negative 6, negative 10, add 24, 16, which is 18, 6. Of course, that would be in meters. Now in part B, we want the time at which it is due south of the origin. Remember, the origin is here. So, in other words, when it's reached this point here. The I component will be 0. Remember, the I component is right or left, and this is directly below the origin. So, if r is equal to negative 6, negative 10 plus t times 3, 2, we want the I component to be 0, which gives us negative 6 plus 3t is 0. 3t therefore is 6, and therefore t equals 2. Now we're looking at a situation where it's due east of the origin. The j component will now be 0. Remember, the j component is up or down. So what we're going to get is that negative 10 add 2t equals 0, giving us 2t equals 10, and therefore t is equal to 5.